Hello mathematicians, this is the notes video for Chapter 3, Lesson 7, Part 2. The learning target is, I can graph systems of equations and identify the type of solution. Here's a little review of systems of equations. Remember that systems of equations share two of the same variables, and you can solve for the point that they overlap on a graph. So you can solve for them. Today we're going to be talking mostly about the different types of solution. Now there's three different types of solutions. The graph of a system of equation indicates the number of solutions. If the lines intersect, there is one solution. If the lines are parallel, there is no solution. And if the lines are the same, there are an infinite number of solutions. So just to reiterate, slopes and intercepts, when a linear system of equations has different slopes and y-intercepts, there is one and only one solution. When a linear system of equations has the same slope and different y-intercepts, there is no solution. And when a linear system of equations has the same slope and the same y-intercept, there is an infinite number of solutions. Here's an example. It says solve each system of equations by graphing. And so I see the slope-intercept form, y equals 2x plus 1 and y equals 2x minus 3. They both share the same slope, but they have different y-intercepts. So when this happens, the lines are parallel with each other and will never touch. So there ends up being no solution to the problem. So down below it says there is no solution. For example 5, we're given an equation with that's written in slope-intercept form and an equation that was written in point-slope form. So we had to, or the book did, switch the point-slope form and convert it into slope-intercept form. And we realize that the lines are the same. Y equals 2x plus 1 is the same as y equals 2x plus 1. So both equations are the same. Then if you graph the line, you see that there's an infinite number of solutions. Let's try one on our own. Solve each system of equations by graphing. So D says y equals 2/3 x plus 3, and that's written in slope-intercept form, so I'm going to leave it. And then we've got 3y equals 2x plus 15, so we have to switch that to slope-intercept form. 3y equals 2x plus 15. And to get y by itself, we have to divide both sides by 3. So y equals 2/3 x plus 15 divided by 3 is 5. So we have y equals 2/3 x plus 5 and y equals 2/3 x plus 3. So they both have the same slope, but they don't have the same y-intercept. Therefore, the numbers have no solution. But now I'm going to graph it just to make sure. So I'm going to start by plotting the points. I'm going to graph this line in red and this line in blue. So I'm going to start at 3 on the y-intercept, and then 2/3 is up 2 over 3. Down 2 over 3. Alright, so then I can make a line that's about right, and then I'm going to graph my other line in blue. My intercept is at 5, which is right here. If I go up 2 over 3, right about there, down 2 over 3, there. Okay. So the lines are parallel and they will never touch because they go on forever and they have the same slope. Okay, so let's try E. y minus x equals 1, so we have to turn that into a point-slope equation. So I can turn that into a point-slope equation, the first one, y minus x equals 1, by turning it into y equals x plus 1, because if I added x to both sides, I could get y by itself. So then I need to turn the other equation into point-slope form. So y equals x minus 2 plus 3 turns into y equals x plus 1. And so since they're the same line, I'm going to graph it in black. So the slope-intercept, or the y-intercept, is 1. And then the slope is just x, which is 1 over 1. And so if I plot my points, and then I can graph my line. And so since those both share the same line, it's an infinite number of solutions. All right, so those are the answers to D and E. Okay, let's try a problem from our guided practice. Y minus 6 equals 2x. I can turn this into point-slope form by adding 6 to both sides to get y by itself. Okay, so now I'm rewriting it. Y equals 2x plus 6. And so now I'm going to solve for the other equation. Y equals 2 times x plus 1 plus 4. I have to distribute the 2 to the x into the 1. Y equals 2x plus 2 plus 4. Oh, I accidentally wrote 6. Whoops. 2 plus 4 is 6. So y equals 2x plus 6. And so it looks like I got the same equation. And so so I just circled them, and now I'm going to write an infinite number of solutions. So infinite number of solutions. There, so now I'm going to graph my line. So I'm going to draw my y-intercept at 6, and then go up 2 over 1, up 2 to 10 over 1, up 2 over 1, and then I can mirror it on the other side. Down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. I'm just going to keep plotting and then graphing my line. And so it's not perfect, but it's about right, and it goes on forever. And so my answer is an infinite number of solutions. Here's another example. It says a system of equations consists of two lines. One line passes through 2, 3 and 0, 5. The other line passes through 1, 1 and 0, negative 1. Determine if the system has no solution, one solution, or an infinite number of solutions. To compare the two lines, write an equation of each line in slope-intercept form. So we have to take the points that were given and turn it into slope-intercept form. So the first step is to solve for the slope. And so the slope equation is y2 minus y1 over x2 minus x1. So 5 minus 3 over 0 minus 2 is equal to negative 1. And then for the other equation, y2 minus y1 is negative 1 minus negative 1 minus 1. And then x2 minus x1, which is 0, negative 1. Or a slope of 2. So these two equations both have different slopes. It says find the y-intercept for each line, then write the equation. So to find the y-intercept, you can substitute in the points into the into the slope-intercept equation, and we solve and get that the y-intercept is 5 for the first equation, and that the y-intercept is negative 1 for the second equation. So when x is 0, y is 1, or negative 1. And for the first equation, when x is 0, y is 5. So we were able to solve for the equation. So since the lines have different slopes and different y-intercepts, they intersect in exactly one point. Then we graph. The lines intersect at 2, 3. So there's exactly one solution, and that solution is 2, 3. Let's try one on our own. So the first step, we've got points 0, 2, and 1, 4, and then 0, and -1, and 1, 1. We have to first put those into slope-intercept form by solving for the slope and y-intercept. So for the first equation, I'm going to use red, and I'm going to take m equals y1 minus y2, so y1, or y2, which is 4, minus y1, which is 2, over x2 minus x1. So 4 minus 2 is 2, 1 minus 0 is 1. So the first slope is 2. Okay, so now for the second equation, I'm going to solve for the slope. M equals y2 minus y1, 1 minus a -1, and then 1, so x2 minus x1, which is 1 minus 0. So 1 plus 1 is 2, 1 minus 0 is 1. So m equals 2 for both equations. Now I have to solve for the y-intercept. And so I can find the y-intercept by using the equation y equals 2x plus b. So when x is 0, y is 1. So I can substitute in the variables. So I'm going to use 0 and 2. So 2 is y equals 2 times 0 plus b. 2 times 0 is just 0. So the y-intercept for the first equation is b equals 2. So the y-intercept is 2. Okay, now I'm going to solve for the y-intercept of the second equation using this point. So y equals 2x plus b. I can substitute in my x and y using that point. -1 equals 2 times 0 plus b. 2 times 0 is just 0. So -1 is b. So they both have the same slope but different y-intercepts. So I can graph it, but I also know that there's not going to be any solution because the lines will be parallel. So no solution for this one, but I'll graph and show you as well. Okay, so for the first equation, I'm going to rewrite it. So it's y equals 2x plus 2. And then my second equation is y equals 2x minus 1. So I've got a slope-intercept of positive 2. And then my, so my y-intercept of positive 2. Whoops. And then my slope is 2. So up 2 over 1, down 2 over 1. Okay, so that's my line. So I can draw my line for my first equation. And then for my second equation, my y-intercept is -1, up 2 over 1, up 2 over 1. Okay, just making sure that it's graphed correctly. And the lines will be parallel, so there is no solution for this one. Okay, last problem. A system of equations consists of two lines. One line passes through -1, 3, and 0, 1. The other line passes through 1, 4, and 0, 2. Determine if the system has no solution, one solution, or an infinite number of solutions. So it doesn't sound like we have to graph this one, so that's kind of good news. So let's just be able to determine what it's got. So for the first equation, we've got -1 and 3, and then 0, 1. So I'm going to take 1 minus 3 over 0 minus -1, 0 plus 1. So 1 minus 3 is -2, and then 0 plus 1 is just 1. So the answer, the slope m is negative 2 for my first equation. Then for my second equation, 2 minus 4 over 0 minus 1. And so where am I getting those numbers and why am I putting them in that order? Remember that my slope equation, m equals y2 minus y1 over x2 minus x1. So if you're unsure about that, you can go back to a different lesson and check that out. So 2 minus 4 is negative 2, and then 0 minus 1 is negative 1. So I'm just checking to make sure that's right. So negative 2 over negative 1 is positive 2. So m equals positive 2. And so they both have different slopes, so I know that there's one solution. So I don't think I need to find the y-intercept. If you would like to solve the rest of it, take that as a challenge problem and go with it, but there's one solution for this problem.